Here's part 2 of the video series of re-recording ones with sound. Okay, this is empirical and molecular formula. We will discuss a variety of ways to calculate empirical formulas, what they are, as well as molecular formulas. But let's start first with empirical. An empirical formula is a formula in the most reduced form. So here's an example. Here is glucose. Okay, this is the formula for glucose, C6H12O6. If you were to put this in the most reduced form, the ratio of carbon to hydrogen to oxygen is 6 to 12 to 6. So you're going to take that ratio and put that ratio into the lowest terms, okay? This is just like what you do when you flip-flop something and you turn it from Mg2O2 into MgO. All right, so if you flip-flop it, you put it in the most reduced form. The empirical formula of Mg2O2 is MgO, and that's the proper formula. When you're not flip-flopping them and I just give you one, usually you believe me unless I'm asking you for the empirical formula. In this case, it should be CH2O. All of those numbers are divisible by 6. If, for example, you divided them all by 2 and you saw that they were still divisible by 3, you could continue to reduce it until you can't reduce it anymore. Remember, they all need to be whole number subscripts, okay? They need to be whole number subscripts. So if you have a formula, make sure you reduce it, okay? That is the most important part, okay? You want to reduce it. If I didn't tell you it was C6H12O6, and I asked you to find the molecular formula, a molecular formula is just a multiple of the empirical formula. Okay, so if I told you the molecular formula has a molar mass of 180 grams per mole, in order to find the molecular formula, there are a couple steps you need to take. Okay, the first step, how do I number these? I don't remember. Okay, so over here on the left, here's your empirical formula, MgO. Options for molecular formulas are MgO, Mg2O2, Mg3O3, Mg4O4, etc. Okay, they all reduce back down. So the molecular formula, what you're really looking for is the factor. What is the factor you're going to multiply this thing by in order to figure out what the actual molecule is? There it is. Step 1. You need to find the molar mass of your empirical formula, and this is the part that everybody forgets. We need to figure out what the molar mass of that empirical formula is. In this case, our empirical formula, ignore MgO, we're looking at CH2O, I just outlined in red. That's your empirical formula. So let's find the molar mass. Here's a review of molar mass. The mass of carbon, which is 12, plus 2 times the mass of hydrogen, which is 1, plus the mass of oxygen, which is 16. That totals, wait for it, 30, I think? 30? Yes. That totals 30 grams per mole. Okay? That's the molar mass of my empirical formula. I need to figure out what factor to multiply my empirical formula by in order to get my molecular formula. I'm telling you the molar mass of this stuff, of the molecule itself, is 180. But it reduces down to an empirical formula that weighs 30. Now you divide the bigger number by the smaller number. Okay? It's going to be the molecular formula by the empirical formula, which is always the case. Okay? So it's going to be 180 divided by 30. If you do that, your factor is 6. So you multiply each of the subscripts by 6 in order to get the proper empirical formula. In this case, we're going right back where we started to C6H12O6. Remember, if there's nothing written there, it's really a 1. 6 times 1 is 6. To check your work, reduce that back to its empirical formula and make sure it matches. You should be able to go both ways. C6H12O6 has an empirical formula of CH2O like we started with. There's another way to figure out an empirical formula, and it depends on if you have percentages or grams, okay? Otherwise, if you have a formula, you can just reduce it. Here's an example. This is from your midterm review. Let's say we're going to start with 30 point. We did an analysis, and we know that by mass, 30.4% is nitrogen of this sample, and 69.6% is oxygen. Can you calculate the empirical formula? I'm going to walk you through this process that everybody seems to forget, okay? What is the empirical formula of this stuff? First step, you've got to change the percent signs into grams. Okay, assume a 100-gram sample, and then you figure out that you have 30.4 grams of nitrogen and 69.6 grams of oxygen. The next step is to divide each by their molar masses. Okay, nitrogen weighs 14, oxygen weighs 16. Remember, in this case, it's not O2, it's not pure oxygen. The oxygen's part of this compound. So, when you figure out, you convert the grams to moles, figure out how many moles you have. I have 4.35 moles of oxygen and 2.17 moles of nitrogen. Okay? 2.17 moles of nitrogen. Now, I'm not done. Do not just round here to 2 and 4, okay? That's not an empirical formula, and 204 is not an empirical formula. You have one more step that everyone forgets. You look at both of these numbers, divide them both by the smaller of the two to get the smallest whole number ratio. In this case, it's going to be 2.17 divided by 2.17. Divide them both by 2.17. And you get a formula of N1, that's the subscript, because 2.17 divided by itself is 1, and O2, because that second one gives you a subscript of 2. Okay, so your empirical formula is NO2. Before I end this, just make sure you are aware that that should be an empirical formula. If it's not, you did something wrong, okay? Reduce it down. If you have a subscript of like 1.5 or 2.5, multiply both subscripts by 2. All right, if you do that, you should still have an empirical formula that you can't reduce any further, but you won't have the 0.5 or you won't have that weird decimal. You can round it. Make sure you carry significant figures with you. Round it within reason. All right, so not like from 0.4 down. Perhaps I would round 0.2 down to a whole number or 0.8 up. Okay, otherwise find a factor to multiply it by. I don't believe that will be on your midterm, but you may see that on the region.